Welcome to Probability Day 3. You and your partner cut out the letters of the word central and put them in a bag. You will be choosing a letter at random from the bag. The sample space are the letters, and all of these letters are different. The probability of choosing an N is 1 out of 7 because it's one letter out of the 7 possible. The probability of choosing a vowel, there are 2 vowels out of the 7. You and your partner want to pick a letter. You pick the letter N and you do replace it. What is the probability of your partner choosing an A? That probability is 1 out of 7 because it's almost like you didn't pick anything at all because you reset the sample space by replacing the N. You and your partner want to pick a letter. You pick the letter N, and this time you don't replace it. That means you hang on to it. The sample space does change because the N is gone, and now there's only 6 letters to choose from. The probability of choosing an A is 1 out of 6. If we consider the two events A and B, the probability of A and B occurring is given by this computation, the probability of A times the probability of B, and that is provided events A and B are independent, and we will talk about that in just a minute. But the phrase here, the key word is and this symbol right here represents intersection, just like you guys saw in geometry class. So both event A and B are occurring, which means they have to be happening at exactly the same time. So that indicates an intersection or an overlap. Consider the question above regarding the letters of particle. Find the probability of choosing an I and then choosing an A with replacement. So now we're picking 2 letters and we're definitely replacing those letters. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters, and there is 1 I, so we have 1 out of 8. And we're going to choose an A, and there's only 1 A. So we multiply by 1 out of 8 because we're replacing. In the next problem, we're doing the same thing, but we're not replacing. That means we're going to hold on to the first letter. Is it going to be the same? It will not be the same because the sample space is changing. So it'll be 1 out of 8 for the I. Because we've hung on to the I, there is 1 less option to choose from. So we have 1/8 times 1/7. Find the probability of choosing a consonant and then a consonant if 2 letters are chosen without replacement. So again, we're holding on to the letters in our hand. So we have 8 to choose from at the beginning. Consonants are not vowels. So there are 1, 2, 3 vowels. That means there are 5 consonants, but we don't put it back. So we have 1 less to choose from in the entire pool, but because we've chosen a consonant here, we also have 1 less to choose from in the entire pool of consonants, and so then you can multiply that out. Now we define independence and dependence. Independent events are those events that do not change each other, and dependent events would change the other one. So knowing the probability of one event or knowing what happens in a situation would impact the probability of another event. Number 3, there are 24 numbered balls in a daily lottery drawing, each with equal weight and probability of being chosen at random. Will the number being drawn on Saturday be independent or dependent of the number drawn on Monday? This is going to be independent because what you pick on Saturday does not change what would be picked on Monday because the balls are a daily lottery drawing, which means that the numbers get put back into the lottery. What is the probability of picking a 2 on Saturday and a 4 on Sunday? So we have 1 out of 24 times 1 out of 24. They're independent. So you're able to multiply these probabilities together because what you pick Saturday does not change what you pick on Sunday. The exact same answer happens on the next question. Even though the numbers change, it doesn't matter because it's still just 1 out of 24 is the likelihood of getting a 12 on Saturday and then another 12 on Sunday. So times 1 out of 24. Letter D, what's the probability of picking the same number on Saturday and Sunday? This is a question that comes up a lot. in various scenarios. The thing is, you don't actually care what number is picked. So this can happen for a 1, it can happen for a 12, it can happen for a 17, it can happen for a 3. And you have to account for all of those possibilities. So there's two different ways to approach this. You could say pick a 2 and then pick another 2. But then that could happen for all 24 numbers. And so in the end, this ends up just being 1 out of 24 is the probability. The other way that you could explain this is to say that you actually don't care what number you pick on the first day. And because you don't care, its probability is 100%. Something will happen. And what you have to do for the second day is match it. And there's only going to be one number that matches exactly what you picked on the first day. And either way you look at it, the probability is still 1 out of 24. So really think about those questions and how a subtle phrasing changes how you can think about that question. Number 4, consider the following events. C, all college events arrive to statistics class on time. D, the roads leading to the college are icy and dangerous. Are the events C and D independent or dependent? I would say that they are dependent. Knowing that the roads are icy and dangerous is going to impact students arriving to class on time. Number 5, the heart of a pocket calculator is one or more chips, each of which contains several thousand components. These chips are mass-produced and have a fairly high probability of being defective. Defective means that they don't work. Suppose that a particular kind of calculator uses 2 chips. Chip A has a probability of 70% being defective, and chip B has a probability of 80% being defective. If one chip of each kind is selected at random, what is the probability that? In answering all of these questions, you make the assumption that chip A and chip B are independent, that knowing what happens with one of them has no impact on knowing what happens to the other one. It doesn't change the probability. So the likelihood that both are defective means that A is defective and B is defective. So we multiply the probabilities. Part B, the probability that A is not defective. So if A is not defective, that's actually 0.3. We know that 100% of the time something will happen, and 70% means defective. That means 30% means that it works. The thing is, the probability that B is not defective will be 20% or 0.2 for the exact same reason as this other one. And the probability that both work means that you need A to work and B to work. And then you can multiply those together. Bye.